I would just wanted to jump in here. This is going to be a video just discussing how we approach example number 3. Just in case you did it and you didn't get 960 kilometers and 51 degrees south of east. So just going to work through this one. So we have, just present this here. All right, so we have the first leg is due east for 620 kilometers. So a different way of setting this up, I know I kind of set it up a little different before. I had my X and my Y column, and then I have, in this particular case, I have 3 vectors of this. So I'll have 1, 2, and 3. So I can solve each of these 1, 2, and 3. Obviously, I like to draw the vectors individually, breaking them apart into their components. So my first one is due east, 620 kilometers. So perfectly east, 620 kilometers. So that means I have positive 620 here. And then for the y, there's no y distance. For my second vector, again, just drawing them separately, I have the second leg being 440 kilometers is southeast at 45 degrees. So southeast 45 degrees means my leg looks like this. This is 45 degrees, but this is broken apart into a horizontal component and a vertical component. So this is my x2 and my y2. Remember that to the right is positive and up is positive as a general rule. But I mean, that doesn't have to be the case as long as you know what your result vector is. So then, as I am solving for this, what was it, 440? So my hypotenuse is 440. So in order to find x2, I take 440 times the cosine of 45, and that gives me, let me see, 311 kilometers. So my x2 is 311. Again, that's in the positive direction, so I'm keeping it positive. And then my y2 is downward, so it's negative 440 sine of 45, which is going to be the same as it was before, except for opposite, negative 311 kilometers. So then this is negative 311. And then for my last leg, oops, not 1, but 3, I have 550. That's 53 degrees south of west. So again, I'm orienting it correctly. South of west. So obviously this is the west direction, and south of that would be 53 degrees. So I'm going to measure my angle 53 degrees south of west. So now I didn't quite draw this the way I want to, so I'm going to erase this line. Maybe if I can figure out how to erase it. Just to draw it as dotted, because I'm drawing my components dotted. So that's composed of that. That wasn't quite dotted, but you get the idea. And that's 550. What I notice about these is this x3 is in the negative direction and y3 is in the negative direction as well. So if I'm solving for x3, it's negative 550 cosine of 53. And that is negative 331. So my x3 is negative 331. And then my y3 is, again, it's in the negative direction, negative 550 sine of 53. And this gives me negative 439. Negative 439 kilometers. These are both kilometers. So then I put that over here, negative 439. Now, what I do is I sum these all up. So if I sum all the x components, taking into consideration the positive and negative directions, I get exactly 600. That's my x component. And in the y, I get negative 750 kilometers. So then my job at this point is to take these two values and put them into a vector. So, or put them into a triangle. So I'm going 600 in the positive direction and I'm going 750 in the negative y direction, 750. So then I'm trying to find the hypotenuse of this. And then I'm also trying to find what angle south of east am I measuring that from. So I use Pythagorean theorem. I have 600 squared plus 750 squared, and that gives me, and I take the square root of it, that gives me the 960 kilometers. That's the magnitude. And then in order to find this angle right here, I'm just going to use tangent. So the inverse tangent of opposite over adjacent, 750 over 600, gives me the angle theta, which is 51 degrees. And then that tells me this angle right here is 51 degrees, but I also need to give that a direction, and that is south of east. Obviously, this being east, and it's south of east. So S of E. That last little bit is important, so there's my two answers. Okay, hopefully that helps.